So what are plugins? Plugins are basically just a collection of code or an asset. It's a very broad definition, and the only thing it means is that if you have sort of a library, that by itself is a plugin. Plugin is something that you can take from place and move it elsewhere, which leads us to our next point, which it's something that lets you easily expand the engine features. And it's something that we can easily move from project to project. Usually you would want to develop your own plugins when you have a behavior that you know will be useful in other projects. It is fairly rare to develop something that you know will be useful only on one project. There are instances where that makes sense, and we will cover them later. But as a rule of thumb, usually you want something there for the sake of modularity. That leads us to our second point, and that's why do we need something like plugins? And the main reason, I would even say it, is that it lets you keep your code rather modular. It's very common to mess your code in a way where it's incredibly difficult to read, and it tends to be disorganized. So structuring everything in plugins, that means a unit of code that can be moved from place to place, usually lead by the definition to much more readable and maintainable code. So then it's something that lets us customize our Unreal editor. By default, most of us work with Unreal editor as we kind of get it out of the box. Plugins are really useful tool to create our own tools, to let us customize what that engine does. The main benefit from it is that, or main reason for it rather, is that by default, Unreal is really useful for any kind of a game. And when something is useful for everything, it usually means it's not best for a specific thing. Universality as sort of a rule automatically loses benefit of something being specific, of specificity. So usually Unreal tends to be good overall, but for your specific projects it usually tends to miss some things. For that we usually have plugins and different editor utilities that lets you create and modify the engine to suit exactly the project that you need. It can be something from selecting different meshes in a way that Unreal doesn't let you do natively. It can be loading of assets. It can be anything that makes more sense. We're going to look for examples of plugins later. And if you actually would like to dive deep into programming and into understanding how the engine itself works, then plugins are a really good way how to start with that. Making plugins is really simple. It's fairly straightforward, but it can eventually go really deep into practically rewriting most of the ways how the engine works. So if you would like to understand how Unreal actually works on the backend, then writing your own plugins is a really useful step towards it. And another huge benefit is that it lets you very easily package your code and ship it to someone else. We have it here as a note as FAP, which is the new marketplace that Epic is providing for us. And what it lets you basically do, well, structuring your code as a plugin lets you easily package it and send it to someone else, or potentially sell it. It tends to be useful to be able to produce something while you are working on your game. Games usually take a long time to develop. Somewhere between 2 or 3 years is a good median for smaller games. And if you structure your code as plugins, it can potentially prolong the development, but it lets you ship part of your code a lot easier and potentially earn some income and experience as well. So before we actually get into what the plugin, how we use plugins, we need to understand what are modules and what are plugins. For those of you more familiar with C++, you already have a bunch of experience with modules. You can think about module as a self-contained code with a specific functionality. It means it's usually a code that you want to put together, and that code should have a specific functionality. I'm gonna use an example that's actually not a module, but it will drive the point home. A character movement component would be a good example of how module works. All the code there is used for a specific use case, so we can call it as a separate its own module. Okay. Then, like I just said, each module usually serves just one purpose. And here we have some examples that you may have worked with before. A core, an engine, that's something that you can quite work without in Unreal. UMG is the whole framework for setting up widgets, and AI is a whole set of features which usually you would end up as using just as AI Move 2, or what would be the other example, the AI perception stuff. Core and engine, usually there is additional one, which is an editor. Editor is a special module and set of features that exists only when you are working in actual Unreal editor, and it's the part of the code that doesn't get packaged when you actually build it as a game that gets shipped to a consumer. Then we have plugins. So what plugins are, it's just a collection of one or more modules. Now we know that modules are a set of individual code, and plugin is something that lets you package multiple of these modules together. It lets us extend editor without changing engine code. If you actually tried to modify the engine, you would have to basically ship the whole engine, hopefully without the binaries, to someone, and then he would be able to modify, he would be able to work with the change in the engine. That would be very impractical. So plugins let us work and share changes of how engine works without shipping the whole engine code, which usually ends up being about 100 gigabytes on the small scale. Here we have some examples of plugins. We have editor scripting utilities. We're going to cover them slightly today, but they basically just let you modify how editor works. Online subsystems, if you have worked with anything with multiplier, online subsystems is what makes it possible and don't force you to write your own netcode. And Niagara. I'm going to note here one thing, and that especially if you're working with a internal engine, the internal modules and plugins, the distinction between plugins and modules gets very blurry. Niagara is technically more module than plugin, but we interact with it more as a plugin than module. It gets a lot cleaner when you are working with third-party plugins, but when it's something that comes from Unreal, directly from Epic, the distinction gets kind of blurry. Okay, let's see if we have any questions in the chat already. It was rather quick, so probably not. Okay, if you have any questions right now, since we covered it quickly, feel free to unmute yourself and ask it. Otherwise, we are gonna move to practical examples. I'm gonna give you like 2 minutes. Okay. Okay, no one is jumping the gun, so I think we can just move into a practical example. Okay, so usually to make to really take advantage of what we can do with plugins, you will need C++. Nevertheless, you can still do a lot of stuff purely with blueprints. This is a purely blueprints project. It's called PP. I just created a third-person template. Blah, works fine, exactly as you would expect from it. And I'm going to use it as an example to create sort of a library that will let me move my assets from project to project. It can be especially useful when you are prototyping, when you are working on a client project. That sort of stuff tends to really be useful with shared libraries. You already know, hopefully, how to work with plugins. You enable and deactivate your plugins, but what you may have not noticed is that we have here an option to add a new plugin. What we can do is create here a new one. By default, this is because we are working with a blueprint project, we have here an option to add only content only. It's a blank plugin that that contains only content. In Unreal, content would be almost everything except C++ files. So any 3D assets can be here, libraries, blueprints, all that would fit here. So I'm gonna call this my BP plugin. And the rest of it I'm not gonna fill. It's gonna hopefully create my plugin, and I'm gonna see that I have here my new BP plugin. I can just directly package it from here. So if I wanted to share this plugin with someone else, I can package it, and then it will create for me a not quite executable, but something that Unreal can easily read. You don't necessarily need to do that actually, especially if you are planning to work on your plugin further. But if you wanted to share it to someone else, this is how you're gonna go about it. Okay, and now our plugin works exactly in the same way as we would be working with any sort of a folder inside our Unreal. So in our plugins, plugin content, I would like to, let's say, have a shared material library that I'm moving from project to project. So I'm gonna simply create here myself a folder for materials, and inside it, I would like to create some material base. Right, and that will let me have some material base that I can move anywhere I want. And if I want to update my plugin, it's gonna keep all this up to date across all of my projects, as long as I update it before opening the project. It gets a bit clumsy if you open it first and then update. But let's say this is a good way for me to store my materials. In a similar way, let's say that I have a huge library of assets that I would like to access. Assets, in this case, I am referring to a 3D models, textures, this sort of stuff. I can create it here. And then when I open my plugin, right in here, I can see it in my BP plugin example. It's a project. And in here we have a new folder, which is plugins. And I have here my BP plugin. I can grab this folder and put it into any kind of a project I've created inside the plugins folder. Plugins folder usually doesn't get created automatically. We have to create it manually. But once you do that, you can just copy it anywhere. Really useful for shared libraries, anyway, to move content between projects. Okay. Let's look at another example, which is going to be function library. If you are not familiar with function libraries, that's something that's going to make your code a lot more modular. So let's say that I have some functions that I know that I take advantage of a lot. So I'm going to create myself universal function library. Oh, come on. Universal function. Let's just call it the universal library. And what I would like to do is to have something that will let me calculate a forward vector and distance from a specific component. Something we do all the time when we are trying to figure out some tracing. So let's call it get location and forward vector. Okay. Function that's going to handle exactly that. And I know that I will want to always get it from a specific component, because I'm probably going to be executing this within blueprints. So I'm going to get here a reference for a component. Okay, we should see somewhere here a actor component. Come on. Actor component, there we go. It's a upper class for any kind of a components that you may have in your actor. So I'm gonna call this component. And now from this, I will want to calculate my forward vector and my location. So I'm gonna get world location. And I can't get world location, why not? Okay, you know what, I'm gonna simplify it and just work with an actor. Component would be better, but I don't wanna spend time debugging it now. So let's keep this as an actor. There we go. Component would be more universal, but let's not go crazy here. So this will let me get a actor location and actor forward vector. Okay. Logic that you do probably hundreds of times within your project anytime you need to do some tracing. So this I would like to multiply by a distance. I'm gonna add here an input, which is gonna be a float. And this will be how far I want to look for stuff. Okay, and I'm gonna connect my distance here. That's, by the way, pretty useful. If you are working with functions, you can use any input parameter as a variable. You can just access it here. You cannot set it because it's an input variable, but you can nicely set it like this. And I need to add it up together to make sure I get the proper location. Cool. And now let's return all this. So I'm gonna want to return my location, and I want to return my forward vector. Let's try to be slightly less messy with the code here and do something like this. All right. So that's gonna be our location, and it's gonna be our forward location. I'm not calling it forward vector anymore because that's not necessarily accurate, because now we have it added with an actual location. Vector by itself is forward vector by itself is just a direction. Okay. Now we have this function that I can use in any kind of a blueprint inside my project. So let's say that in my third person character, I have decided that I want to do a trace in front of me. Anytime I jump, for some reason, I want to trace what's happening in front of me. So I'm gonna call the function. Yet I don't need to add it here anywhere. It's not like interface. It's automatically accessible everywhere. So let's get actor location, and I forgot how it's called already. That's very realistic. Let me see. Sure. I'd have better called it like that. Get location and forward vector. Okay, there's no actor. Get location and forward vector, and now I have the function here. So I can refer to myself, and let's say I want this to be 300 centimeters, so 3 meters in front of me, and I can do sphere trace. Sphere trace by channel. And now I have automatically my start location and my end location. Normally you would copy this whole code and have to do it in here. Now that I have here my function library, my function that I can call in any kind of a blueprint, I can easily create this. I could even make it actually pure, because I don't need any execution on this. This is pure math here, so now that's even better. There we go. 300, wait, that's way too big. The radius is gonna be like 100. Cool. And now every time if I actually set it up to be visible, then I'm gonna see that every time I trace, it's gonna trace in front of me. So visibility, debug, duration. There we go. Okay, jump, and we're tracing in front of the actor. Really useful for any code that you repeat honestly more than once. It's almost always worth to have something like a universal library that's worth to have in any project. But specifically, if you have it inside a plugin that you create for yourself like this, you can easily move it between projects. Very useful when you are working on client projects or you're switching projects for whatever reason. This didn't need any C++ knowledge, useful for any sort of stuff, as you can imagine. There is no limit where this sort of a function can be called. As long as it inherits from actor or it is a blueprint of some sort, you can call it there. You can also nicely set it up with categories. So by default, if you when you saw that I called it get location and forward vector, it's just under a universal library, which is fine, that works. But I can also categorize it. So let's say that this I want to set as my, let's call it trace helper. And now I have it nicely here. As you can imagine, you're gonna eventually build yourself quite a few libraries like this, quite a few functions within these libraries like this. So it's useful to have it categorized. So I should be able to now find it. I can just write trace helpers, and it's gonna show me all the functions that I would eventually have here. Cool. That's pretty much it for the blueprint example. There is nothing too crazy. Let me see if we have any questions, and then we can look at examples of a plugin that I made that's written in C++, but we are gonna cover it purely from structural point of view to show you what's possible and how it's set up. You don't really need to know any C++ to understand how it works. Okay. If there are questions, what happens to references of content outside the plugin folder when after packaging? Well, plugin gets packaged with, unless you specify, which we are going to actually cover in the C++ example, unless you specify that the plugin should not get packaged, it will get packaged with the project. Yeah, we are gonna get right here with our with the example of the plugin, the next one. Then I'm gonna show you what it packages and what it doesn't package. But as a rule of thumb, unless it's part of the editor, it gets automatically packaged. So okay. In that case, let's look at our next example. Better Debug, this is a plugin I made. It's available on Marketplace. I'm gonna share you links afterwards, so you can look at it. Just so you are aware what it does, it's just basically a helper library that lets you debug a whole lot faster. So we have here just a bunch of functions where you can print specific data types without messing up with our print string. So for example, we have here a better print string node, which is basically a fancy way how to do print string. And you normally have to append it and make sure that you can specify it, etc., etc. You have to specify what it should show you, what's the information about it, and we have here a key without it being hidden. The whole point of it is just to make debugging a lot faster. You also have here quick nodes like print works and print fail, which you don't have to write as print. Let's say you just want to test something, you can just write works and you can write. And you can confirm it and it's going to show you right away. And the whole point is just to make debugging a whole lot faster. And then printing stuff that normally are difficult, like rotation transforms. You can specify which pitch of the rotation it should play, blah, blah, blah. I'm just going to show you an example where we can, on the left upper corner, we can see that it's printing us a different information as I'm pressing different numbers on my keyboard. What is a decently important part of this is this widget utility that lets you create your own window where you can modify a bunch of this fun stuff. So you may decide to print only on screen and not print on log, for example. You can adjust where it is on the screen. It's very useful for VR development if anyone has any experience with it. Let's say I want to have it now in here instead of on the left upper corner. I can globally adjust its size, which is probably a bit too much, yeah, but there we go. I can set up categories, cool stuff. Yeah, so let's look at this plugin. This is a combination of both blueprints and C++. So we're going to start looking at our C++. The most important thing is our Better Debug U plugin. This is something you will deal with even if you work just with blueprints. And that's going to be our information about modules. Like we covered on the start, those modules handle specific feature sets. So in our case, we have two of them. We have a Better Debug runtime and Better Debug editor. We can see that they specify whether they are runtime or an editor. That's something you have to do no matter what plugin you are developing. For blueprints, it doesn't matter because it's always runtime. But for something like C++ plugins, you actually need to specify it. Then you also specify what plugins should be enabled as well whenever this plugin is being activated. So the difference between runtime and editor is our packaging setting. So on runtime, it gets packaged properly with your project, which makes sense because we want our debugging to work while we are making a development debugging. But for our editor utilities, we don't want them to be packaged while we are actually creating a final package of our game. This is more of a unnecessarily workaround, because a lot of the utilities within engine that this plugin relies on are not supported when you're packaging the file. So I needed to split it into two models so Unreal doesn't try to package stuff that he cannot package. It would just basically cause you a bunch of packaging errors when you tried it, which is not particularly nice. Okay. So we have a runtime and editor. Editor, as you can imagine, handles our widget utilities, which means this fancy stuff. Wait, I'm in the wrong blueprint. It should be this one. It handles our widget utilities, potentially some assets, work exactly the same. Those are in the runtime, but we have them here. And no, they are not in the runtime. My bad. They are in the utility because it's here. And then our runtime handles all that printing. Now we actually look at what these two modules do. So just to have some structure, everything here is saved in our source file, and in it we have two separate editors. Now you work in exactly the same way as you work with any kind of a class that you created in your project. If it's private version, it's your public version, and then you have build that you ignore. Let's look at our runtime. That's the more important thing, and the only thing really you care about here is our print utility. What our print utility does, let's look at our header first, is that it has a list of functions that get called. Only thing it doesn't variables, we don't care. You can see that these variables based on types that we were printing before, those functions exist here. You don't need to understand any of this ufunction void stuff. Ignore it. Just think about it purely from structural point of view. We have here a bunch of functions that print a specific type. Most of this you could recreate just with a blueprint-based function library. There's a few stuff you cannot do, and we're gonna get there, but most of this stuff you can do very easily. Most of these functions just call our better print string. And what our better print string function does is figures out what should be shown on the screen and when it should be shown on the screen, plus all these nice extra parameters that we included. That kind of leads us to our better debug HUD, which is something I had to include specifically because I wanted to be able to move my positions around the screen. This is something that's not necessarily normally useful, but if you work with any other device than PC, specifically VR, but for mobiles it's also quite useful, you tend to need to adjust this position, and there's not really any native solution for that. So the only way how to solve that was to create a custom HUD class. Again, something that you can do fairly well just with blueprints. It's just much easier in C++. And then we just create this HUD class, and that HUD class figures out what's being printed on the screen. If our HUD class is active, it will take into consideration our text position. If it's not active, we have here something else, which we have a condition for, right somewhere here. And I don't want to spend time looking for it, but it should be somewhere here. Yeah, there we go. We're gonna check if our HUD is what we want it to be, and if our HUD is what it wants to be, it takes it into consideration. If it's not, it's just gonna simply print it in its default position, even if we have our text adjusted. Okay. That's mainly for our print utils, a huge function library. Then we have our module for our better debug edit, and then HUD is just this code for adjusting and showing what should be shown on the screen and what shouldn't be shown on the screen. That's basically this nice stuff right in here. Okay. Then we have our private module, which is our editor, and what that does is mainly handles a communication between widget utility and all our function libraries. As you can imagine, we have here some global variables that need to exist. Things like global default size, text, what should be printing, blah, blah, blah. These things have to exist as a global variables that can be accessed at any point. So for that, I needed to create a way to communicate between changing of these utilities variables and making sure that the better debug runtime is aware of all those changes. That basically led to having to create a widget utility, which is inherited from a widget utility, which is a class that exists within Unreal, and you can see it right in here. From that, I had to create a children. That's making sure that it's using that parent I created in C++, and then it creates this, which is something you can create purely with blueprints. I needed to do it in C++ so I can handle communication between the private information and global variables, so they all are kind of synced. If you have worked with widgets in any fashion, you are familiar with how to work with this. It's using different names. It's using, instead of checkbox, it's using editor utility checkbox, but otherwise it's exactly the same thing. Then in our graph, it's really straightforward. The only thing we are doing is setting a boolean, setting variables, and reading the variables when we are creating this widget. There is nothing special or fancy about this. It's just a regular widget. The whole point of this widget is just to set these global variables. Okay. That's pretty much what I wanted to cover. So let me share with you when you can get this. Both this project and its code are public, so you can get it on pub, and you can get its code if you want to download it and mess around with it. It's completely open source. You can download it and do with whatever you want. So that's for this plugin. Let's see, we can finish up with looking at some examples of where plugins make sense to use and when they don't make sense to use, and then we can leave open mic for any questions. If you have any questions popping in your mind now, feel free to type them in the chat as well. So some benefits of our plugins is, of course, reusability. You want to make a plugin if you know that the code you are going to be using will be very useful across different projects. If that is the case, definitely a good place for plugin. Another kind of a thought there is if you know that this solution would be something that potentially other people will be interested in, even better, something that you can charge for, you can also make it as a plugin so you can right away make it available on FAP. It's something that leads to generally much more modular code. By the definition of having everything structured in different plugins, you tend to naturally have much more modular code. It's just by the way plugins work. These all kind of work together because you have the code more modular. You tend to have much higher clarity in your code. That basically means it's easier to read. It's much harder to mess up. Because you don't tend to have now 50,000 things inside just one actor, because each of them are handled in different plugins. It's similar workflow when instead of putting all the logic, all your functionality inside one character, you're gonna set yourself a different actor components. For example, a health component, a damage component, inventory. Like these things exist just as an actor component, which is, by the way, a really good example what you could include in your function library. Not function library, in your content library. If you create yourself a components that are used almost anywhere, like a health component, instead of always hard coding it for the character, you can just make universal health component and keep it inside your plugin. And it's very useful if you want to set up some tooling for your game. Like we covered, Unreal is great, but it's not best for everything. So it's almost always the case that some tools that Unreal offers are good for you, but they could be slightly better if you modify them specifically for your game. And if that's the case, plugins are just the way how to do them. Either editor utilities or libraries, anything in that direction. So now let's look at some potential disadvantages that that you will be facing with plugins. One of them is that plugins by definition are hard to set up. They take more time, and arguably they are slightly more difficult to refactor. So if you are just prototyping and you would have no clue what code is gonna stay or whether this code will be ever used again, probably not the best time to make it as a plugin. And generally it takes longer to set up. These two go together. If it's harder to set up, it usually takes longer to set up. And harder to set up here also means that it requires a bit more knowledge to actually do it. So once you get used to that workflow, it's probably as easy as just writing the code directly inside your project, but there is some extra compilation time, and if you are doing it for the first time, it will take you a lot longer to achieve actual result than how you are used to. Then something that's actually the biggest drawback are our dependency issues. Because our plugins are so modular, you tend to run into dependency issues between plugins. So if in your project you decide all of a sudden that you want to have only plugins, like all of your game logic is going to be spread across 10 different plugins, you lose a lot of the modularity that the plugins offer you. Because you run into dependency issues, where in order for one plugin to work, you need to have the remaining 9 plugins enabled. That kind of defeats the purpose of something being modular. That's the one part of dependency issues. The second is that you can run into differences between engine versions, even the micro differences between engine versions. So like 5.1/5.1.2, there was probably some change in the way how the engine handles stuff. You are quite likely to run into trouble. Not necessarily likely, but if something that you have been working on and your plugin handles has been heavily modified, you are probably gonna run into some errors. And those are things that you cannot avoid, especially for the micro engine updates. And then you get into actual engine updates. So going from like 5.1 to 5.2, then all of a sudden your plugin doesn't work and needs some rework. That's something that will happen. It's the updating a plugin for a new version of the engine is usually a lot easier than it may seem, but if there was some fundamental change in how the engine works of the part that you are actually modifying with your plugin, it's very likely that you are going to have a lot of work ahead of you. That does not happen if your logic is not done with plugins, and if your logic doesn't really modify any C++ files. Because whatever was handled on the backend was handled with internal implementation in mind. Just to show you, so you have some idea, the only way that tells you what version your plugin is this thing, engine version. This is 5.1 and I'm running it on 5.4, I think, right now. So usually it works completely fine. It's not a problem, but it's a lot more likely that you are going to run into these problems with plugins than if you not use plugins. So something to be aware of. And usually C++ is required. I showed you an example where C++ is not required, and when you are working just with a library, you want to use internal blueprints stuff, internal Unreal stuff. You have no problems with it at all, and you don't need any C++. But if you actually want to modify stuff further and actually want to change how the engine works, other than just modifying the assets, it's almost always the case that C++, at least some knowledge of C++, or at least some knowledge of how the engine works is required. Okay, that should be our pluses and minuses. So let's look at some questions. Let me first read it, and then if you guys have questions, feel free to ask it now. Is it possible to ship plugin with the dependency, or the user will need to install it by himself? The plugin gets packaged with the project, so you don't need to package it. If you mean as a user, as someone who plays the game, then it doesn't matter at all. If you mean someone who works on the project and you don't include the plugin, Unreal actually should handle this for you. So if your project, which we should see here, if your project requires some plugin, then the project file should specify it. And I'm not sure where do we see it here. It should be the uproject file, and there we go. So your uproject file, that's the thing that you usually click on when you are starting the engine. It shows you, can have specified what modules and what plugins it requires. So in this case, I have here that whenever this project is launched, it requires better debug dev to be active. So whenever someone starts it, he will be able to, and the engine will check whether that plugin is installed, and if it's not installed, it will ask you to download it. If the plugin is free, like Better Debug, like I have here, it will just automatically download it. This is free plugin, so there is nothing to worry about. If it's paid plugin, then usually you have to either buy it or it's shipped with it. You can directly ship it with your project, of course, which is often what's done when you are working with clients that require access to your project. That's a bit depends on how exactly the agreement set up. Okay. It's third party. Well, need to ship it into the team. Yeah, pretty much. If it's a third party and it's paid, then you usually want to ship it together with the project. So in that case, that's about it. Thank you.